Math 3, Unit 9, Section 6, Part B. Okay, we're going to continue condensing equations and expanding equations when needed in order to solve these equations. You have these steps we had on the previous notes. In case you didn't go through them, I'm going to kind of walk through them with you real quickly here. So your first step is to always use your laws of logarithms in order to condense the equations to a single logarithm with a coefficient of 1. What is a coefficient? What does that mean? Coefficient is your number in front. So right now this logarithm has a coefficient of 1. This one also has a coefficient of 1. So remember, we always have to make them a single logarithm with a coefficient of 1. Then on these problems, now previously we were able to cancel out the logs on both sides once we got a single log on both sides. Today though, we are going to get a single log on one side of the equation and not on the other. So you can't just cancel them out. In order to cancel them out, you have to have a log on both sides. But in order to get rid of the logs this time, we can rewrite the equation in exponential form. So rewrite exponential form. Once you do that, you can solve the equation. And then the last step is to always check your solution because you need to make sure that your logarithm will be positive. Okay. All right. Another thing is sometimes in these problems, you will get pi or e. Just leave answers in terms of pi or e. Okay? You do not have to approximate them or put them into your calculator. All right. Starting here at this first problem, we have 2 logs here on the left side, so we need to start by condensing them. Okay? How do I condense those two? When you have 2 logs that are subtracting, we can condense them by dividing. Very good. We have log base 4 of 28 divided by x equals 2. On this problem, I am not able to cancel this log out. Why? Very good. I don't have a log on the other side. And so, but I can get rid of the log by turning it into exponential form. So how do I rewrite this one in exponential form? This is going to, so it's always your base, and this is always your power, and this part is always the answer. So in this case, the equation will be written as what? Very good. 4 to the second power equals 28 over x. And then we simplify. What is 4 to the second power? 16 equals 28 over x. Now, we have a fraction here. How do I eliminate the fraction? Very good. Multiply by x to both sides. Now we no longer have a fraction. We have 16x equals 28. And my last step would be to do what? Good, divide by 16. And then you would always reduce if you can. Can I reduce 28 over 16? Yeah. What can I reduce by? Okay, so 28 divided by 4 is 7, and 16 divided by 4 is 4. So my answer is x equals 7 over 4. We just want to check this. If I put this back into this equation, would I have a negative number in that log part? Nope, so I'm good. This answer works. All right, I'm going to give you a minute to try to condense this one and solve for x. If you get the answer, raise your hand. I will come by and check it. Okay, so our first step always is to make them a single log. How can I condense those to make a single log? You end up condensing them, it turns to multiplication. So these 2 logs right here, because of my adding sign, we can condense them and they turn into multiplication. We end up with log of, and then x times 4 we would probably write as 4x equals 3. Now at this point the log does not have a base. If the log doesn't have a base, what is the base? 10. Very good. 10. Okay? So I can't just eliminate this log, right? Because we have to have a log on both sides. But I can get rid of it by turning it into exponential form. So how will I rewrite this one? Very good. 10 to the third power equals 4x. Okay, and what is 10 to the third power? 1,000 equals 4x. And last we will, very good, divide by 4 to both sides. And my answer is x equals 250. And if I go back and look at my problem, 250 in this spot is an okay answer to have, and so I'm good. All right, on this next problem here to the right, I already have a single log. Isn't that nice? So first step is already done. Actually, the second step is already done. So now we have to just the first step, sorry, okay. Anyways, what am I gonna do? Very good, natural log is base e. So when I rewrite this now, how will I write it? E to the negative second power equals x. And x is already by itself. The only issue here is what? The negative exponent. How do I get rid of that negative exponent? Make it a fraction. And so this would get moved to the denominator. And we would end up with x equals e to the second moves to the denominator. If nothing's on top, it's just a 1. Does this represent a root or anything? No. So I'm good. It's only if I have a root in the denominator that I have to get rid of that as well. There's our answer. Okay. Do you have questions before moving on? All right, I'd like you to go ahead and try this one on your own. Right here. Okay, first thing is always to do what? Condense. You need to condense. I want to see everyone condensing on the left side. Condensing. Condense.
Don't tell me.
Okay, so perfect, good. What does this right here, when I condense it, what does it condense to? Okay, log base 3 of 3 times x minus 5 equals 4. Is everybody good with that first step?
Yeah.
Okay, can I just cancel the log out?
No.
No, why not? There's not a log on both sides. So my only option, Cole, my only option is to do what? Exponential form. Okay. So exponential form is where this becomes my base and this becomes my exponent and then this goes on the other side. So therefore, this will be what?
3 to the 4th equals 3x minus 15.
Okay, good. Yes, that is also correct. Okay, 3 to the 4th power is what?
81.
81. And then we distribute and we get 3x minus 15. We want to solve for x, so next I will add 15 to both sides. 81 plus 15 is 96 equals 3x. And then the last step would be to divide by 3. And what does x equal? And what do we always need to check? Will it make a negative value up here? 32 minus 5, is that okay? Yeah. Yes. So we're good. Questions before moving on? All right, last one on this page. There's one additional step on this one that wasn't on a previous problem. What is it? Very good, the 3. What do I do with that 3? Very good, it becomes an exponent. So for my notes, I'm going to rewrite each step here. So that became natural log of 2 to the 3rd plus natural log of x equals 5. Remember that you can simplify this, and we know that 2 to the 3rd power is actually what? 8. 2 times 2 is 4 times 2 is 8. Okay, next we need to do what? Condense, right? And so because this is addition, when I'm condensing, what happens? It changes to multiplication. So now I have the natural log of 8 times x, which would be 8x, equals 5. Can I eliminate the natural log? No. Why not? It's only one log. Good. So we need to turn it to base e, change it to base e. And from there we can eliminate the log by doing what? Changing it to exponential form. Good. And so we would write that as, what was that again? Very good. E to the 5th equals 8x. Is x by itself? Nope. So what's my next step? Very good. Bless you. X equals e to the 5th over 8. I don't have any negative exponents. I don't have any roots in the denominator. This is my answer. Any questions? Okay, we're going to go ahead and move on. Okay, what will I do on this next one? This first problem here on the left. Very good. You need to first take care of any of the coefficients that are not 1. Okay, so this 2 gets brought up as an exponent, and that looks like that's it. So now I have log base pi of 5 squared plus log base pi of x equals 3. We know that 5 squared is what? 25. So at any point you want to, you can reduce that. I'm going to go ahead and do it right now, and I'm actually going to just rewrite this. Log base pi of 25 plus log base pi of x equals 3. So now I need to condense this further. And how do I do that? Good. So when we have addition and we're condensing, the addition changes to multiplication. So I have log base pi of 25x equals 3. How will I eliminate the log? Exactly. So we take pi to the 3rd power equals 25x. And what can I do now in order to get x by itself? Very good. Divide by 25. And so x equals pi to the 3rd power over 25. Riley, are you getting all this? Okay. And again, we don't have any negative exponents. We don't have any roots in the denominator, so we just leave our answer in terms of pi. Okay, last one. All of these have a log coefficient of 1. So our first step is just to condense. And so when I have subtraction here, how do I condense it? Very good. Division. Log base 7 of 3x over x minus 2 equals 0. How do I eliminate the log now? 7 to the 0 power equals 3x over x minus 2. What is anything to the 0 power? Good. I'm just going to rewrite it. You can skip that if you want to. Am I going too fast? Okay. So now we have 1 equals 3x over x minus 2. How do I eliminate the fraction? Good. Multiply by x minus 2 to both sides. That eliminates those fractions. When you distribute the 1 through, 1 times x is still going to be x. 1 times negative 2 is negative 2. So we have x minus 2 equals what? 3x. Is that okay?
Isn't it 3x squared?
Mm-mm. Why do you think it'd be 3x squared?
Oh, wait, never mind.
Okay. All right, now what?
Subtract that.
Good, we're going to subtract x to both sides. These eliminate. We get negative 2 equals 2x. And then the last thing we would do is divide by 2. And so x equals what? Negative 1. And we always need to do what? Check it. If I put negative 1 up here, 3 times negative 1 would put a negative 3 here. And that would not work. It also, if you put it here, it'd make another negative 3. That will not work. And so this answer that we got doesn't work. And there are no other answers, which means this answer is actually going to be what? No solution. So it's important that we always check. All right, any questions here?